In this instructional video, we intend to learn about the digital outputs of the G100 inverter, digital outputs such as relay outputs and transistor outputs of the G100 inverter from the LS brand. As you can see in this diagram, it has two types of digital outputs, relay and transistor. In the standard G100 inverter models, there are only two relay outputs and no transistor output. However, in the G100 compact type or G100C, the inverter has both relay and transistor outputs, which are shown here with the Q1 and EG terminals. So the standard G100 inverter, the regular model, has two relay outputs and no transistor output. But in the G100 compact model, which ranges from 400 watts, 0.4 kilowatts, up to 2.2 kilowatts, the G100 inverter has both relay and transistor outputs, which are the Q1 and EG terminals. For the relay outputs, the A1C1 terminal is normally open and the B1C1 terminal is normally closed. But what settings do we need to make for the digital outputs of the G100 inverter? To configure the digital outputs of the G100 inverter, such as the relay and transistor outputs, we need to enter the OU or IUT parameter group, which relates to the outputs of this inverter. In parameter OU31, you can assign a function to relay 1, in OU32 for the transistor output, and in parameter OU33 for relay 2. But how should you set these parameters? For example, if you want to assign a function to parameter OU31, which is for relay 1, you can specify that if a certain event occurs in the inverter, for example, a fault happens or the inverter simply runs or stops, a relay should be activated for you, or specifically relay 1 should be activated. How do we do this? According to the table you see, if you set parameter OU31, which is for relay 1, to any of these numbers, the relay will operate according to the function defined opposite that number. For example, if you set parameter OU31, which is for relay 1, to number 14, relay 1 will be activated. That means as soon as the inverter runs, relay 1 will be activated. Or for example, if you set parameter OU33, which is for the second relay of the inverter, to number 15, after the inverter stops, relay 2 will be activated. So these are the settings we can make for the relay outputs and define when they should be activated. In this instructional video, we intend to do an example together. We want to set parameter out or OU31 to number 14, meaning the relay will be activated as soon as the inverter runs. And set OU33, which is for relay 2, to number 16, which is steady. Steady means that when you give a command frequency, for example 30 Hz, as soon as it reaches 30 Hz and starts operating at that frequency, your relay will be activated. But how will our wiring be? If we want to use the transistor outputs of this inverter, for example, if you have a signal lamp and you want to connect it to the transistor output of this inverter, and you want this signal lamp to be activated as soon as the inverter runs, you need to supply 24 volts to one side of the signal lamp. Our transistor output is 24 volts, and our relay output can be either 24 volts or 220 volts AC. If you want to use the transistor output, you supply 24 volts to one side of the signal lamp, and from the other side of the signal lamp you connect it to the Q1 terminal, which is the transistor output of this inverter, and we connect the common of the transistor output, which is the EG pin, to the CM of the inverter. And this completes the wiring related to the transistor output. If we have a relay output, we can supply either 24 volts DC or 220 volts AC. If we want to use the relay output, whether 220 volts or 24 volts, depending on the operating voltage of the signal lamp, we connect one side of the signal lamp and the other side of the signal lamp to terminal A1 or A2, which are related to the relay outputs of the inverter. The common of the relay outputs, which is C1, is connected to the CM terminal of the inverter. So we have learned what settings need to be made for the digital outputs like relay and transistor outputs of the inverter, and we have learned how to wire them. Now, let's move on to the device and apply the settings we've learned together and test this feature together. So as we said, to configure the digital outputs of the G100 inverter, we need to enter the parameter group OU. We press the mode key until the OU group appears. Once the OU group comes up, for relay 1, we set parameter OU31, and for relay 2, parameter OU33. I go to the OU group, parameter OU31, which is related to relay 1. We said that for the G100 inverter, we want relay 1 to be activated as soon as the inverter runs. To have it activate as soon as it runs, we need to set OU31 to the value 14. I set it to 14 and press enter. Okay, now we've set relay 1 so that it activates as soon as the inverter runs. For relay 2, we want it to activate as soon as the frequency reaches our command frequency. For example, if we set the frequency to 40 Hz, when it reaches 40 Hz, or in other words, when it reaches the steady state, relay 2 should activate. We said that for this, parameter OU33, which is related to relay 2, should be set to the value 16. So relay 1 activates as soon as it runs, and relay 2 activates as soon as the inverter reaches the command frequency, for example, the 40 Hz that we define. Now I'm going to set a 40 Hz command here for the inverter. Relay 1 should activate as soon as I run the inverter. I start it, and you can see that relay 1 activates. When it reaches 40 Hz, relay 2 also activates. Now I stop the inverter. You can see that relay 2 deactivates first, and since the inverter is no longer running, relay 1 also deactivates. I'll start it one more time. And after it reaches a frequency of 40 Hz, relay 2 activates. I start it, relay 1 activates, and when it reaches 40 Hz, relay 2 also activates.